Algebra 2 Regents, sample question number 10. Given h of x and k of x, state the solutions to the equation h of x equals k of x. Round to the nearest hundredth. These are some pretty ugly looking functions right here. H of x is a power 3 function with fraction coefficients. So this is the fact that it's a degree 3 tells me that it'll be something like this. You know, the arrows will be ending in opposite directions. Remember, odd degree means like that. Now, this is not an odd function because it has even exponents, but it is an odd degree function. And then absolute value typically looks like a v. However, the negation in front of it, you know, when we negate the front of a function like that, it flips it upside down. So this is going to look something like that. And then, you know, this plus 5 means up 5. This plus 2 means things like that. So it's going to be some pretty weird looking graphs here, and they don't say algebraically here, which is the good news. So we can use our calculator to do this work for us. If it said solve algebraically the solutions, we would set these two things equal to each other, and we would really have a tough time with it, honestly. Um, to solve an absolute value equation, you actually create two equations, one equal to it, one equal to the negation of it. It would be a mess. You do need to know how to do that, but for this, we're going to let our calculator do this. And when they say state the solution to h of x equals k of x, basically we want to know where these things cross. You know, what are their answers? Where do they intersect? Things like that. So let's get our calculator out and type these things in and see what we get. So y equals, and it's going to be 2/9 x cubed. I hit math 3 when I want to do cubed. You could also use the exponent key. Plus 8/9 x squared minus 16/13 x plus 2. Now you could put each of those fractions in parentheses if you'd like. It's okay here that they're not. Um, so let's see, 2/9 x cubed plus 8/9 x squared minus 16/13 x plus 2. So that alone, let's just look at this graph first by itself. Like I said, it's highest power is 3, so it's degree 3. So you see one arrow ending here. The other arrow is going to probably end somewhere up here. There we go. So that's that graph. And then in the y2 spot, let's type in the absolute value. So first I want to do the negative key, because it's negative that. And that's not the same as the minus key. It's kind of confusing sometimes that there's two buttons here, but anytime you start with a negative, that's the first thing, you always start with this button down here. That's the negative key. And then absolute value, you can get to it in the catalog, but if you hit math and then over once to the number file, it's your top choice, ABS. And then in here we could type 0.7x and then get out of those absolute value bars and hit plus 5. And let's take a look at these two things together. And there we see the upside down V. So first thing is they are hitting in 3 locations. So if you're drawing this sketch yourself, you can't drag over on your screen like that. You don't have to draw this, but I think it will probably be helpful if you did. Looking something like that for that one, and then this one is coming over and it's hitting 1, 2, 3 times like that. And so we're looking for these 1, 2, 3 solutions here. And we're going to let the calculator do this math for us again. So the way to do this is if we hit second, calc, here's where we get a couple of different things. We could do zeros, we could find roots this way, we could find minimums and maximums this way, and then there's intersect. And that's what we want to know, where two things intersect. And then we get the little flashing X, which I call Toodles, from the Mickey Mouse Clubhouse, reminds me of Toodles. And we just move Toodles over to a spot of intersection, as close as we can. And when we hit enter, it jumps to the other curve in about the same spot. Usually you don't have to move it again. You hit enter, and then enter a third time, and it'll tell you intersection down here is X is 5.17, Y is so on, so on, so on. We want our answers rounded to the nearest hundredth. And so let's see here. That's going to be, I'm going to get that calculator up. But 5.17 is the x value here. So x equals 5.17 and y equaled 1.38 when rounded properly, 1.38. So that's one answer. That's this one right here. And basically, I just need to repeat this for the other two options. So second calc 2, the other 2 points of intersection, move over to that other point of intersection where the graphs cross. Get in that area, hit enter. Hit enter again. I think I did maybe root. Second calc, yeah, I think I hit 2. I meant to hit 5. Second calc 5. There we go. And over here, enter, enter, enter. 1.13, 4.21. 1.13 and 4.21. That's x and y. And one more. So second calc 5 for intersection. Move over this one. Now those should have been negative, but let me go back and check that a second. So enter, enter, enter. This is 1.75 and 377. So 175,377. 1.75, 3.77. And I just want to go back and check those. Were those should have been negative x values. So second calc 5, let me go back to that. I don't know if maybe I just didn't see the negative sign. This is clearly on the negative side of the x-axis. 1, 2, 3. I think there's a very, very faint negative in front of that number. I couldn't. This screen's a little small here, but I could tell that these two first points are negative. Over here, there's negative about -5, -1, and then here's about +1. And solve the equation h of x equals k of x. I think they really want these x values more than they want the y values, but mine as well list them all there. But that's basically it. So it's not a difficult question because the calculator is going to do it for us. And this is a useful tool to know how to do that. If you have two different things typed in, by doing second calc, you can find out a maximum of a curve, a relative maximum, a relative minimum. A 0 is the same thing as a root or an x-intercept. An intercept of where two different graphs cross. So there's some helpful calculator tools in there. Solving this algebraically would have been a real nightmare. So that's it for sample 10. See you.